Good morning. Land cover and climate change are two major factors that threaten biodiversity, impacting species richness and abundance, as well as species habitat and distribution. To date, studies evaluating the impacts of these global changes on species habitat and distributions in India are limited to species-specific case studies or as part of global scale analysis. And these kind of studies do not adequately capture the local variation of the impacts. Thus, it is critical to address this knowledge gap. Closing this knowledge gap has implications towards conservation of both species and habitat. For example, by comparing the projected changes in habitat between species of different habitat specialization, it could lead to reassessment of current Indian policies that are biased towards forest species and habitat. Also, establishment of current protected areas often overlook future global change impacts. So understanding future changes will highlight areas needing conservation now to preserve their potential for protecting species in the future. Birds play an important role in the ecosystem, and they are both sensitive and responsive towards environmental changes, including land cover and climate change. Globally, 5,000 species of birds and 1,400 species of birds in India have declining populations. So, birds can be an important representative for understanding the impacts of land cover and climate change on habitat suitability. The aim of this study was to assess the impacts of land cover and climate change on habitat suitability of birds in India under present conditions and future scenarios. The results are summarized based on species habitat specialization and spatially across biomes. Then species richness was calculated, and then conservation recommendations were made. Habitat suitability was modeled by correlating species data downloaded from GBIF along with different predictive variables. Then, an ensemble of machine learning algorithms were used to project habitat suitability under present conditions and future scenarios. Habitat suitability of 478 species of birds was analyzed, and these belong to different habitats. The figure you're looking at shows the average amount of suitable habitat was projected to decrease. However, when summarizing the results based on species habitat specialization, you can see that suitable habitat was projected to remain unchanged for forest birds, while a decrease was projected for non-specialized habitat and non-forest birds. I'm only showing a subset of the results because there's not enough space. Based on these results, I would recommend that conservation efforts avoid bias towards forest species and include non-forest species as well. On average, suitable habitat was projected to decrease within desert and xeric shrublands, as well as tropical and subtropical biomes, while changes in temperate and other biomes were very small. Again, I'm only showing a subset of the results because there's not enough space. When suitable habitat across biomes was summarized based on species habitat specialization, you can see the differences between forest, open habitat, and wetland birds. Based on these results, I would recommend desert and xeric shrublands, as well as tropical and subtropical biomes be effectively managed to better conserve both habitat and species, particularly desert and xeric shrublands, as these are generally classified as wastelands. When you look at species richness under present conditions, you realize that this is not an adequate representation of the actual species richness that India has. This is because the study was limited to the assessment of 478 species out of the 1,211 known species in India. The number of species analyzed is a limitation of this study. Since species richness is biased, rather than focusing on areas with high or highest richness, looking at the differences in richness or the lack of could be used to identify potential areas that could serve as effective conservation areas under future scenarios. To conclude, to effectively conserve species and habitats, the impact of land cover change must be reduced to habitat conservation, while mitigating climate change requires both habitat conservation and reduction of greenhouse gas emissions. A preprint of this study is available online if you want to go through the details. Thank you.